Welcome back to Autistic Coder's LeetCode interview preparation series. Today we're solving problem number 200, number of islands, a problem that appears frequently in coding interviews. This problem requires us to count the number of connected groups of lands in a 2D grid. We'll solve it using a breadth-first search approach. Let's get started. We're given a 2D grid where a 1 represents land and a 0 represents water. Our goal is to count how many separate islands exist in the grid. An island is defined as a group of connected ones that are adjacent horizontally or vertically. Here are some examples. To solve this problem, we'll use a queue-based breadth-first search traversal to explore all connected ones and mark them as visited. Here's the JavaScript implementation of the solution. Let's go over my implementation so you can understand it. First, I initialize num to count islands. Next, I create a visited array to keep track of processed cells. Then, I iterate through the grid and run BFS from every unvisited one. Next, I use a queue to traverse land cells and mark them as visited. Then, I increase num whenever a new BFS starts, signifying a new island. I use the optional chaining operator to prevent out-of-bounds errors when accessing grid of x minus 1, grid of x plus 1, etc. If x minus 1 is outside the grid range, JavaScript would normally throw an error, but the operator at y safely returns undefined instead. Let's analyze how efficient this approach is. The time complexity is O of m times n, since every cell is processed once. The space complexity is also O of m times n, due to the visited array and queue storage. This problem is a great example of how graph traversal techniques like BFS can be applied to grid-based problems. It's a useful pattern for other problems involving connected components in a 2D space. Please feel free to ask any questions you have about my solution in the comments section. Thank you for watching this video, and let's keep learning and growing together.